Okay, so yes, we were discussing charging and discharging. We discussed 63% is the time constant. This means when you're charging a phone from 0 to 60%, the time required to do that is known as the time constant. Time constant is also equal to resistance and capacitance. So we can also say the product of resistance and the capacitance is known as the time product. Okay, then we discussed that the charging, this the discharging. Charging simply means when you attach your charger with the plug or the switch and your phone starts charging. Discharging is opposite, where whenever you just charge your phone, you are now removing, like you're using your phone. This means that discharging would be happening. Okay, like that. So discharging would be happen. So you have attached this the capacitor, this the resistance. You have attached this to the battery, which is DC circuit, DC circuit or DC source, which is battery volt potential difference. This the resistance. So we can say in starting when you charge your phone, or when like you have removed your charger, okay, your phone in your hand. In starting, that will be very fast. That charging will move very fast. When it will become 0 to 10, like from 10 to 0, when these charging will be used, that will really move very slow, very slow. Okay, so we discussed till this. Now we know that when a capacitor is connected to a resistor, then C plus R capacitance, this is the resistance. So resistance will lose charge. Losing of the charge, losing of the energy that will be stored is known as resistivity. Like resistance, resistivity, we know that oppose the current. This means that remove the current. Okay. So we discussed this, and we know RC, if R and C is greater or smaller than the 1, then the current or the charge would be very fast. Charge would be very fast. Okay, so RC, this will be, and RC will become down when this would be lower than the, like this will be greater than the 1, or this all, or still if you're not getting, let me just clarify a little more. This is RC. RC will become slow, or it will reduce reduce RC will reduce to the fast process. RC, which will one, like whenever it will be more less than the 1, that will be the fast process. If RC, when it will be 1 greater, here it was 1 reduce, here it is 1 greater, then the reaction or the process will be slow process. Okay, so I'm sure you've gotten a concept, and yes, this was all. Still, charging was simply when you have the two equation we derive. V is equal to 1 upon 2 CV square. Second was V is equal to 1 upon Q square upon C. These two equations which we have. Okay, charging was when you attach a capacitor with the battery and it gets charged. When you attach a phone with a charger and the charger is plugged with the source, which is battery, or battery simply means the plug or switch we have at our home. And we know in the open circuit there is no current flowing. Why? Just because if there's open circuit, that means the current is passing outside. Or we can also say no current flow when capacitor is attached to the capacitor. Wait, if this the battery, just attached with the battery, and here we have the capacitor, so we know this become the open circuit. So from here, if the battery volt will be going, then it will go here till here. It will be like broken, it won't go furthermore. So we can say that the no current will flow in the open circuit, or when you have a battery plus capacitor, you want like no current will be flowed. So yes, and the battery is a DC source charge, and